Okay, so with grounding, if you go outside of your house, you can see this. Not all houses have this. It was added in about the 60s, 70s, 50s. I'm not sure. In the 60s, I think. If you have a new house and you go outside, where the power line comes into your house at the service head, that's that sort of, I don't know, that's that thing that looks like this sort of, and then the lines come into it. Um, if you look down at the base, you'll see a copper wire that goes to the ground, and you find a clamp that looks a lot like this, a clamp that is attached to a brass rod that is driven deep into the ground, something like 15 or 20 feet. This acts as a ground for all the electrical devices in your house. This ground wire connects the rod to your house, and it serves two purposes. So if you look at this clamp, if you look right here, there is a ground wire that comes off, and that goes inside of your house. Basically, that wire goes to that third prong that's in most of your outlets. So if you have a newish house and all of your outlets have 3 holes, it's that third hole. But it serves two purposes. One is to protect your house from lightning strikes. These are not necessarily in the order of importance. If lightning strikes your house, if it strikes, it's possible that your entire electrical system becomes charged. And what this ground does is it allows, this is obviously not a good thing. Like I remember my grandmother she told a lot of stories, and I'm not sure if this story is true, but it suits the purpose here. She said that one time lightning struck her house, and the current from this lightning bolt that struck maybe the transformer outside and then came into her house through the hot or neutral wires, came into the circuit breaker, went through the circuit breaker, went into her television, and caused her television to dance around and spark. I'm not sure that story is true, but you can obviously understand that if lightning does strike your house and that electricity comes into your home, it can cause some very obvious dangers to you and to those that you care about. So what the alternate ground does, this ground provides a path for the electricity to enter the earth. The grounding wire, I'm just going to call it the ground, provides a path for the electricity to enter the earth. All right, so that's the first thing. And then the second thing is to protect you from faulty devices. I'll describe that here in just a second. Okay, let's look at that. So as I said, in our house, which is kind of an old house, some of our outlets are like this, and some of our outlets are like this. But if most of you live in a newer house past the 70s, then all of your outlets are going to be like this. In fact, new building codes require that you have this alternate ground and that you have this third prong in your outlet. Now, you are able to retrofit a house, actually, and in our house, for example, we've done some of that where some of our outlets we've grounded not to a rod out in the ground, but to our plumbing, because that's easier to do. Now, this third prong offers a direct path to the grounding rod outside of your house. So when you stick the plug in here, it goes directly to that grounding rod which is stuck in the earth. So there's no, nominally, there's no electricity that flows through this. So if you want to take a paper clip, you can do this if you like. Take a paper clip, stick it in that hole, nothing's going to happen. In fact, nothing should happen also unless it's been hooked up incorrectly if you stick a paper clip in this hole, because this is our neutral and this is our hot. So you can do that. You should be able to stick a paper clip in this hole or this hole and have nothing occur. You can try that if you want, but I'll be careful because sometimes outlets are not hooked up correctly. All right, so don't try that. Don't try that. And don't tell anybody that I said to try that. Never mind. All right, the third prong offers a direct path to the grounding rod outside of your house. So imagine this electrical device. You know, it could be a toaster or whatever. You have the hot wire that brings in current. It flows through the device, and then it goes out the neutral wire, right, providing a complete path for the electricity. In addition, you have a wire that is connected to the third prong, and this wire is usually connected, by the way, to the case of the device. Now, if you've ever opened up, say, your computer, you'll see a little green wire that is connected to the case, screwed to the case, the metal case usually. That goes to that third prong. That is a direct path to the third prong, which is a direct path to the grounding rod outside of your house. Now, you can imagine if you have a faulty device, like a wire melts inside the device, and you get a break in the wire, and it actually touches a metal case, something that conducts electricity, then that whole metal case becomes charged. Right? Now, if a person comes along and touches it without the grounding wire, that electricity would flow through the person and down to the ground, thus hurting the person. However, with this grounding wire, that electricity, which comes out of the wire, is going to travel through the metal case over to this green wire and then go through the third prong into the earth. That's the much easier path for it to travel than it is to travel through a high resistance person down to the floor. All right. So this third prong provides for this alternate path to ground so that in the case of a faulty device, you're not injured. All right, here's a quick test. Third prong provides which of these? And we'll pick up next with GFCI.